slides will be shown and distributed to all participants after the event. Now, let me hand over to Tommaso Andreatta. He is the chairman of the Green Growth Sector Committee of Eurochamp, and he will give us some opening remarks. I hand over to you, Tommaso, please. Tommaso, are you there?
Can you hear me?
Now, yes. Very good.
Oh, very good.
Floor is yours.
Thank you very much. Well, I am very happy to open today's event because the theme is important, and my colleagues have made a major effort in realizing it. As we know from science, life came out of the sea, and many myths around the world tell us how the sea would take life away, as in The Last Wave, an Australian Aboriginal myth that may be a memory of the post-glacial era, or maybe a warning of what will happen if we do not speak to heat the Earth's atmosphere. About 40% of the world population, according to the UN, lives within
Tommaso? Yeah. Tommaso? We cannot...
Can you hear me now?
Yes, yes, yes. Sorry. Yeah, now it's good.
Excuse me, tell me when I was interrupted.
That life comes from the ocean, and it can be taken away by the ocean.
And that's all?
Yes.
So about 40% of the world population lives nearby by the sea. We know that?
Yeah, go ahead. Yes, please.
Excuse me?
Yes, please go ahead.
In the last 10 years, the sea level has been rising on average 3.6 millimeters per year. So by the year 2100, the sea may be 36 centimeters higher than at the beginning of the century. Still a lot less than the 10 meters higher that it reached at the end of the glacial era that gave so much hassle to Sid, Manfred, Diego, and friends from the Ice Age. Should be not worried then. An interesting study by the Vietnamese Ministry of Environment, presented in 2016, argues that the sea level will not rise everywhere in the same way, and it shows what happens if the sea rises by 1 meter around Vietnam. Most of the Mekong Delta, the granary of Vietnam, would end up underwater, and the little part remaining would be significantly affected by high salt waters in the water. So even if there is a small increase in the rate of water rise, this generation will witness much more serious consequences. Another consequence of the change in world temperature is the increase in typhoons and the more extreme rains that make seasonal rivers roll down with more destructive water in the center of Vietnam. But we are not happy with climate change. We also pollute sweet water from factories, agriculture, and husbandry. Cities waste. And all it goes to the sea, where it has a devastating consequence on the fauna and flora. Again, Vietnam is the hero of the situation, with the 4th position in the most plastic thrown into the water. Finally, overfishing, unbalanced the food pyramid by killing sharks for the fins and other selected species hunting, killing corals by trawling fishing, and again by seawater temperature change. And unknown to most, but potentially the most serious, endangering the 50 to 80% of oxygen produced in the world by the vegetable plankton in the oceans. Eurocham's Green Growth Sector Committee is very concerned about the developments and is actively seeking to bring European best practice and best regulation to Vietnam, especially through the influence of smart cities and on the water industry. But all its committees are engaged in reducing climate change and the other challenges to healthy life in a healthy future. Nowadays in Vietnam, although the government is trying to enact policies to protect the environment, water pollution is one of the biggest problems of the country. The main factors that contribute to water pollution are indiscriminate growth in agriculture, urbanization, industrialization. The water pollution situation in the big cities is evident, especially in Hanoi and Ho Chi Minh. In these cities, a large quantity of wastewater from the daily activities is directly let out in the canal river irrigation, going towards the ocean. There are many hospitals and hazardous chemical sites that do not have proper risky wastewater treatment. In Hanoi, for example, the total sewage is about 400,000 cubic meters per day, and that is only 17% of the production of liquid waste per day. Other metropolitan areas such as Haiphong, Da Nang, Hue, Nam Dinh, Haiphong exhibit many indices in water pollution that are 5 to 20 times above the permitted standards. In suburban areas where the living standards is still backwards, all the waste is not treated and seeps into the soil, directly affecting pollution. The most common farming methods abuse the use of herbicides, pesticides, and fertilizers, polluting water and causing abnormal growth of certain algae that take oxygen out of it, thereby killing all other life. Obviously, the size of this problem must be tackled together by government, companies, and the people in a virtuous circle in which behavior changes start from each part of society and it is also required or enforced on the others. Only by all cooperating and doing each their own part, there is a way out. Furthermore, since the environment is the common house of all humanity, all governments must learn how to cooperate. Especially important opportunities for dialogue and ambitious commitment are COP26, which is happening in Italy and then later in the UK this year, and the UN Water Conference of 2023. Only working together, we shall have a chance to move forward and attain the Sustainable Development Goals, ideally by 2030. I hope today's work will contribute to the awareness of the issues and their possible solution and convince decision makers of the urgency of taking action. As Albert Szent-Györgyi, the Hungarian biologist, father of vitamin C, told us, water is life's matter and matrix, mother and medium. There is no life without water. Let us take care of it. Thank you.
Thank you.
The word is back to Bruno.
Thank you. Thanks a lot, Tommaso, for really setting nicely the stage for our webinar and really highlighting the importance of water and as well highlighting the importance of innovation and what European companies can potentially bring to Vietnam. So thanks a lot for this, Tommaso. It's now our real pleasure to welcome Ms. Hala Maher Kadumi from the World Bank. She is a senior water economist there, and she will giving us a speech about innovative solutions towards achieving water security here in Vietnam. So I would like to hand over to Ms. Hala for her presentation, please.
Thank you so much, and thank you very much for the invitation to be here. We're delighted to participate in this interesting forum. If you could, are we to share our slides, or will you be sharing our slides?
What is easier for you? If you would like to share it from
if you wouldn't mind, this is working very well. So if you wouldn't mind sharing the slide, that would be perfect.
No worries, I will do so. Just
excellent. Thank you so much. So, as you know, the World Bank works with client countries throughout the world to address them in realizing their development aspirations. And this includes the important area of the water sector, where we have quite a large engagement in advancing what we call a water secure world for all. This is actually the World Bank strategy for supporting governments in the water sector. And I just wanted to go into a little bit of detail on what we mean by that. We define water security as sustaining water resources, delivering services, and building resilience. On sustaining water resources, this includes resource management at the river basin, city, country, and transboundary levels. This includes valuing water, recognizing that water is not only an economic commodity, but it has many other values, including cultural, social, religious, environmental, etc. Storing water, improving water storage, water reuse and recycling, and looking into other technologies to create new water, such as desalination, and sharing water, sharing transboundary water, and encouraging policies to promote water efficiency and improve water allocation. On the delivering services side, we work in two major areas on promoting universal access to water and sanitation through utility reforms, sanitation improvements, and last mile delivery. And secondly, on optimizing water use in agriculture through irrigation reforms, farmer-led irrigation, and water stewardship. And then finally, in terms of building resilience to shocks, adaptation to climate change and water extremes, which are becoming more significant as time progresses. We support the development and the upgrading of hydromet services, climate smart planning, and nature-based approaches. And then finally, conflict and migration, responding to immediate needs, rebuilding infrastructure, government systems, and capacity hand in hand with government. So these are the areas that the World Bank works with government to achieve a water secure world for all. Next slide, please.
Can you see the next slide, I hope?
Yes, perfect. Okay. Thank you.
Thank you.
So this is just to give you a snapshot of the World Bank portfolio in what we call East Asia Pacific region. You'll see we have a large number of these are actually investment operations working across the region, and you'll see that Vietnam we have within that quite a significant number. In terms of where we work, you'll see that at least about half is in the urban water supply and sanitation space. And then the next largest category is on water resources management. Next slide, please. So turning now to Vietnam, what we have observed is that the water sector has been absolutely critical to Vietnam's development in terms of contributing to the economic development, improving agricultural productivity, contributing to livelihoods, etc. However, next slide, please. However, this has come at a cost. We are now at a tipping point, and in a state of virtually a water crisis. What we see is that there's too little. So episodes of lack of water availability. It's too dirty. Water pollution and water quality concerns are increasingly significant. And there's too much floods and extreme events. Next slide, please. So we've recently conducted quite an in-depth on the water sector in Vietnam, and we find that inaction in the face of escalating demands and degrading water supplies will inevitably impede economic progress. There's discharges of untreated municipal and industrial wastewater, intensifying seasonal and regional water shortages, sea level rise and land subsidence from over-abstraction of groundwater resources, climate change-induced rising temperatures, and increased damming from hydropower upstream of the Mekong River that has significant impacts downstream. Next slide, please. So what are we doing to work with governments to overcome some of these challenges? I'd like to just focus on a couple of areas. I know I don't have an enormous amount of time. We could talk about this all day, but let me just focus on a couple of areas. One is on nature-based solutions for integrated urban water management. We're actually conducting work in two parts of the country, in Phu Quoc and Ho Chi Minh City, to demonstrate the opportunities for nature-based solutions. This is actually part of a broader World Bank study that is also conducting case studies in Thailand. The second is on comprehensive and cost-effective wastewater collection and treatment. Next slide, please. So on the nature-based solutions for integrated water management, as I said, we took two case studies. One is the Phu Quoc case study, and the second is Ho Chi Minh. So looking first at the Phu Quoc case study, we considered two sites, and I should just take a step back. These are actually still under development, and so this is a work in progress that I'm sharing with you. We looked at two sites in the Dong catchment, the Dong Dong Lake and the Ong Tree Creek, and did a deep dive into how to manage the issues that are being confronted in those areas through nature-based solutions. Next slide, please. So this is just to give you so that you can locate yourself on where the Dong Dong catchment lake and lake are. Next slide, please.
And here is the vision again. We want to turn the Dong Dong Wetland Park into a multifunctional wildlife conservation wetland park as a major tourism attraction that bring about many benefits, from flooding to water quality management to water resource management, to ecological restoration, and then amenity, and become a really good tourism destination. So to deliver those benefits, we got to be very smart about how do we design this park so that we can achieve that. And more importantly, how do we use this Dong Dong Wetland Park to demonstrate a proof of concept or example to show the island how you can manage water differently to deliver or to support your long-term vision for the island.
Next. So shall I continue or?
Yes, please. Sorry, I'm on so slide 14, nature-based solutions, Ho Chi Minh City case study.
Yes, so this is a similar case study. I think we might have skipped a few slides, but let's speed through these. Maybe go to the skip the next slide and go to the following one. skip that slide.
Just remind everyone the vision that we collectively created from the last training session. And the vision for Temple Park is that we want it to be the largest Internet of Things enabled multifunctional urban swamp forest in the Mekong region with a broad range of benefits. So the updated strategy and nature-based solutions are the ones that's going to underpin and deliver those vision.
Shall I continue?
Yes, please. Sorry. We are now on Tamfu Park strategy. Yes.
Yes, so this is just to... So why don't we move on ahead to cost-effective wastewater collection and treatment? And the point here is this is sort of a different area that we're working in. And the point here is that we're trying to bring in alternative measures for wastewater collection that are cost-effective and actually save and energy efficient. So through this, we introduced, it's a quite a substantial project, $300 million project that that recently closed, that both included the tertiary network, which is typically not included due to its complexity, and anaerobic ponds and upward filters that are maybe less advanced than other water treatment technologies, but they actually are quite effective and resulted in significant energy savings. You can skip the next slide and then go to the final slide.
Technology for results?
Yeah, technology for results. Just wanted to give you, this is one more sort of innovation that we have introduced into one of our programs that is supporting the government of Vietnam on its national target program for rural development. And the point here is that we've been pioneering the use of smartphones to verify results on the ground, address customer concerns, and provide information to the public. Now, this is actually in the rural water supply sector, but of course has applications to other sectors as well. Because the information is collected through these smartphones and it's geospatially referenced, it can be collected much more accurately at various levels. It can be better aggregated to detect patterns and address problems and to monitor and evaluate the quality and quantity of water and sanitation services. Related to this, a web-based platform has been established to disclose water and sanitation information. And a call center has been established and placed on a transparency platform, which has increased government accountability. So the point here is that these are measures that that have worked well at a certain pilot levels, we should say, but might have lessons learned for scaling up more broadly. So with that, I think that I will end here. Thank you for the presenter who contributed to giving the presentation. And thank you very much again for the opportunity.
Thanks a lot, Ms. Haller. I mean, very interesting insights. And I mean, you showed us some actual projects which are in progress in here, and as well various aspects in terms of how technology actually can help us to accelerate maybe some of the development. So very interesting. Thanks a lot for your sharing. And sorry that the switching from one slide to the other is a little bit slow. Guess that's due to the internet connection.
Not a problem. Thank you so much.
Now let's listen actually to Frank Pogade from Water Solutions Southeast Asia and his presentation on green infrastructure and nature-based solutions and how innovative solutions to urban waterways management in Southeast Asia. So Frank, do you want to share the slides from your screen, or do you want me to do it for you?
No, I will share my screen.
Okay.
Well, yes. Good afternoon, ladies and gentlemen. Greetings from Ho Chi Minh City. ideas, hopefully fresh ideas on blue-green infrastructure. And to this end, I'm going to share my screen now with you. Hopefully this one. So I assume you are able to see my screen.
Yes.
So the title of my presentation is Blue-Green Infrastructure and Nature-Based Solutions, Innovative Solutions to Urban Water Management in Southeast Asia. Just a few words about myself. I am representing the Water Hub Southeast Asia, a focal point for water companies and organizations operating in Southeast Asia. I'm also the chairman of Water Solutions Southeast Asia, as well as the head of the Water Working Group of Eurocham's Green Growth Sector Committee. In this working group, we are supporting European water companies on water-related issues. Well, when you have a look at this slide, you will quickly understand what we are going to discuss today, and how we hopefully can deal with the problems and potential solutions. All of you living in Vietnam or Southeast Asia are well aware of flooding and inundation. Let's see what we can do against it. Let's first have a look at the reasons. The urbanization rates of Vietnamese cities are breathtaking, resulting in more and more sealed areas and hence increased stormwater runoff. Second, the rain intensities and volumes, as shown in this figure here, are increasing too and adding to the first problem. There is some background noise. Could everybody please switch off the microphone? So, furthermore, numerous homemade problems are worsening the drainage situation in urban areas. Many of the mentioned reasons could be fixed through proper management actions that are actually not requiring huge investments or budgets. Based on my experiences in Vietnam, the very poor construction quality of much of the water infrastructure can be blamed for the many malfunctions, overloadings, and subsequent failings of the drainage system. If this underlying problem cannot be solved, all potential solutions we are suggesting in this webinar are doomed to failure. This slide actually indicates a number of very simple reasons why the drainage systems are not working. And as you see, it is not always about technology. It's simply about operation and maintenance and the willing to make a difference. The picture here, stagnant water in a sewer, even during dry weather, indicates that the sewer systems are not capable of draining off the water in the case of heavy rain events. Sealing of surfaces. Well, Vietnamese apparently love concrete, which translates into completely sealed surfaces that forbid stormwater to infiltrate into the ground. Since the stormwater needs to go somewhere, and the drainage systems are often not functional, the result is flooding. Another side effect of excessive sealing is the creation of heat islands in the cities that badly affect the quality of lives too. The solution for all this could be blue-green infrastructure, or BGI. It's a growing market around the globe, and it's based on pilots and basic research work done in Europe, Australia, and the US. BGI is definitely a success story in countries like China and Singapore. European directives are requiring the application already. An example from Germany: it is practically forbidden to connect new urban areas or industrial zones to existing stormwater drainage systems. All stormwater needs to be handled on site. This may be impossible under Vietnamese conditions, but BGI will definitely mitigate flooding and related damages to the economy. Here are the definitions for blue and green infrastructure. As you see, water and stormwater is at the core of BGI, since well-managed water can result in many positive effects in an urban setting. The basic message is, let's apply technical and organizational measures to work with the nature and not against it. But why would we bother? What do we get from blue-green infrastructure? Because the benefits from BGI, as mentioned on this slide, are directly improving our quality of lives and make our cities livable and enjoyable. The picture here is from Berlin, where a big urban area has been equipped with lots of artificial surface water bodies that are collecting stormwater and provided for toilet flushing and other applications. We can learn a lot from others. It is quite remarkable what China has done over the last years. Although you sometimes may have doubts about the long-term sustainability of their investments into sponge cities, it is nevertheless a paradigm shift. In this figure, you can see that some of the areas in this city are featuring a retention rate of more than 85% of the stormwater, which translates into reduced flooding downstream the drainage system. Making a difference in stormwater management as the core element in BGI requires actions on several levels, as indicated on this slide. We have to work on building, water and sewer catchment levels. On the level of individual buildings, numerous actions as described here can be taken. The problem, however, is usually the willingness of the owners to take action. Financial incentives may be required, or the legal framework needs to be adapted. In fact, Vietnam is in a very good position to develop and apply these fresh ideas, since the Vietnamese water regulations are still in an early age of development and not hampered by decades-old regulations that cannot be easily overthrown. But actions need to be taken now. On ward levels and in public spaces, the city administration can do a lot. This slide suggests a few measures. It is important to mention that many of these solutions can be applied to existing structures. That's very important, like desealing of concrete pavements. On ward levels, the green spaces are playing an important role. It is obvious that modern stormwater management will come with more green and spaces for recreation, as you see here. Even water playgrounds for children. Here, landscapers are to be called in. On a sewer catchment level, we are talking about technical solutions and installations. It is important to mention that BGI always requires a traditional drainage system, which, however, can be smaller and cheaper, while at the same time it works more reliable. Combined sewer overflows here on the left are a very important measure for stormwater management in a given urban area. And we will learn more about this technology by HST later on. The good news, there's already a lot of guidance on the planning and design of BGI around, and many in Vietnamese language. More and more trainings and workshops are coming up, which are supposed to equip planners and engineers with the required knowledge. When dealing with BGI, you may stumble across the term SUDS or SUDS, which is explained here. SUDS stands for Sustainable Urban Drainage System, a decentralized approach to rainwater management designed to reduce the pressure on the traditional drainage system. This approach sometimes goes by other names, such as advanced sewer systems, something like that. Core to SUDS principle is the integration into urban planning. Probably the most difficult task to be implemented under Vietnamese conditions. It is, however, the precondition for success. SUDS need physical installations for storage and retention of stormwater. They are usually underground or in buildings. The stored water will be released to the drainage system after the rain event or used for irrigation, production, toilet flushing, etc. It could also be infiltrated into the ground. Reducing surface runoff is crucial. The picture here is indicating potential solutions, including green roofs, trough trench systems, permeable asphalt, infiltration trenches, and swales. There are many more technical options, like increasing the water holding and retaining capacities of roofs, which is often neglected, but it's a very strong tool to reduce the runoff of stormwater. There are dry and wet solutions and combinations of both, meaning water will be visible or invisible in the city. Either way, water will shape the urban landscape. There are first examples in Vietnam, like this one in Saigon. It is a very nice starting point. It's a Sala city in District 2. If you are around, go there, have a look. It's a very, very pleasant area. Also very nice for a picnic. The identification of potential SATS applications require a lot of knowledge on urban planning, landscaping, and technical solutions. Hydraulic, hydrological calculations have to be done, and this is not an easy task. Planting a few trees here or there does not help. GIZ has carried out the first pilot project and applied SATS in 5 Vietnamese cities, namely Quang Ngai, Quy Nhon, Tuy Hoa, Nha Trang, and Soc Trang. The table indicates the technical solutions that have been applied in the respective cities. These SATS activities have been implemented, among others, in Quy Nhon. As you see, the SATS approach is not limited to particular activities only. It's always a combination of many different implementations and applications that are interacting with each other. This is an open water body and infiltration system in Tuy Hoa, in Phu Yen province. The challenge here, operation and maintenance. A solution like this needs permanent attendance. Question is this feasible under Vietnamese conditions and in public areas? We have to see. There is suitable software around for the design and dimensioning of, for example, swales and trough trench systems. SATS require complex engineering and calculations. It's not an easy task. You will have to have the suitable tools at hand. This is a trough trench system in Tuy Hoa. And this is an example for a SATS in Nha Trang city, where several options have been considered. With a solution like this, you will hardly believe that the greening of the streets actually goes hand in hand with reduced flooding. Things are happening underground and invisibly. Here, as you see, this is an area where the water can infiltrate into the ground. It is a technical installation which is not actually visible. This is a combination of an existing stormwater drain, the typical Vietnamese solution, with a newly constructed swale where the overflow will be infiltrated into the ground. I personally like this application. It's a trough trench system in front of a building in Soc Trang city under the responsibility of a private developer. And I mean, cut a long story short, there are already a number of very nice applications around in Vietnam. It's a starting point, and I think we all can learn from that. This picture was taken in front of my office, an area that is badly affected by frequent flooding. Swimming home is standard procedure for me, actually. You can clearly see that options to reduce stormwater runoff are everywhere, like here. In this case, the medial strip could easily be converted into a trough trench system, easing the flooding situation in this area. Another good news, policy making and the development of a suitable legal framework is on its way. The Vietnamese Ministry of Construction has started integrating the SATS philosophy into a number of publications, government strategies, and technical regulations. Things are obviously moving. This development was supported by GIZ, and to my knowledge, more applications and policy-making support is on its way over the next years. We are going to send around our presentation so you can have a closer look into the documents and links that we are mentioning here. Thank you very much for your attention. I hope this presented a few insights on the topic that we are discussing today. Feel free to ask questions before the coffee break. Thank you very much.
Thank you, Frank, for elaborating on nature-based solutions and its very impressive benefits that you highlighted, and as well how you showed that there are many projects which are already implemented in Vietnam. I saw there were a lot of comments and questions in the chat function, so keep going. We will have a look at it at the end of the first presentation session, just before the break. But now I would like to actually go to the next speaker, and it's really a pleasure and an honor to welcome Dr. Tran Anh Tuan. He is the Vice Chairman of the Vietnam Water and Sewerage Association, and he will give a speech about green infrastructure development in urban areas. I understand it will be in Vietnamese, but Ms. Trang will help with the translation into English. Dr. Tran, please.
Xin chào các quý vị đã tham dự hội nghị. Tôi là Trần Anh Tuấn, Phó Chủ tịch Hội cấp thoát nước Việt Nam. Hôm nay thì thay mặt cho Hội cấp thoát nước Việt Nam xin nhiệt liệt chào mừng các quý vị đại biểu đã đến tham dự cái hội thảo quốc tế tương lai sạch và xanh, giải pháp sáng tạo cho phát triển đô thị tại Việt Nam, được tổ chức online thì phù hợp với tình hình Covid ở Việt Nam. Chủ đề của hội thảo là một vấn đề lớn hết sức thời sự, mang tính toàn cầu, một xu thế tất yếu để mở ra cho cơ hội các quốc gia, đặc biệt là các quốc gia chịu ảnh hưởng của biến đổi khí hậu, nước Biển Dân như Việt Nam của chúng tôi. Hội cấp thoát nước Việt Nam là một tổ chức xã hội nghề nghiệp của các tổ chức cá nhân tham gia trong công tác tư vấn, khoa học, nghiên cứu khoa học, đào tạo, xây dựng, sản xuất các trang thiết bị liên quan đến việc cấp thoát nước, được tự nguyện thành lập với cái mục tiêu là đoàn kết, bảo vệ quyền lợi hợp pháp của các cái hội viên, hỗ trợ nhau hoạt động để xây dựng phát triển kinh tế xã hội của Việt Nam.
Ladies and gentlemen, on behalf of Vietnam Water Supply and Sewerage Association, I would like to warmly welcome all distinguished guests and delegates to the international conference, The Future is Blue and Green, organized online in the context of the COVID pandemic prevention. The webinar topic is a very topical and global issue. It is an inevitable trend that opens up many opportunities for countries, especially those affected by climate change, sea level rise, saltwater intrusion, water safety, flooding in urban areas like Vietnam. Vietnam Water Supply and Sewerage Association, or VWSA, a voluntary social occupational organization of bodies and individuals engaged in the management, consultancy, scientific research, training, construction, exploitation and operation, manufacturing and trading of materials and equipment for water supply and sewerage sector. Our objectives are to gather and unite water members, support each other to operate effectively, contribute to the development of the water sector, improve the quality of life for social economic development of the country.
Kính thưa các quý vị đại biểu, đến cuối năm 2020 thì các chỉ tiêu về cấp thoát nước đô thị của Việt Nam đã đạt được. Về cấp nước sạch thì khu vực đô thị có tổng công suất khoảng 11 triệu mét khối ngày đêm, tăng khoảng 4 triệu so với năm 2015. Tỷ lệ cấp nước cho đô thị khoảng 89%, tăng được khoảng 8% so với năm 2015. Tỷ lệ thất thoát thất thu nước thì giảm chỉ còn 19% và đã giảm so với năm 2015 là 5,5%. Đối với khu vực nông thôn thì tỷ lệ người dân sử dụng nước hợp vệ sinh đạt là 85,5%, tăng 3,5% so với năm 2015. Có 4 vùng đạt được cái tỷ lệ trên 90%, như đồng bằng sông Hồng, Nam Trung Bộ, Đông Nam Bộ và đồng bằng sông Cửu Long. Về thoát nước và xử lý nước thải thì tổng công suất xử lý nước thải của chúng tôi đã đạt được khoảng 1,18 triệu mét khối ngày đêm, với cái tỷ lệ xử lý đạt khoảng 14 đến 15%, tăng khoảng 4% so với năm 2015, chủ yếu tập trung ở các đô thị lớn. Kính thưa các quý vị đại biểu, tuy đạt được nhiều những cái kết quả trong ngành nước nhưng vẫn còn rất nhiều những khó khăn, hạn chế, đặc biệt là phải đối mặt với thách thức lớn về vấn đề phát triển dân số, giải pháp quy hoạch đô thị, quy hoạch hạ tầng cấp thoát nước chưa theo kịp với phát triển của đô thị, những ảnh hưởng cực đoan của biến đổi khí hậu như hạn hán, lún sụt, xâm nhập mặn và vấn đề ô nhiễm nguồn nước, sạt lở. Với cái ngân sách thì hạn hẹp, năng lực quản lý thì cũng còn hạn chế, về cơ chế chính sách và đầu tư hạ tầng về cấp thoát nước, đặc biệt là trong lĩnh vực thoát nước, xử lý nước thải và ngập úng đô thị thì cũng còn hạn chế.
Ladies and gentlemen, by the end of 2020, the targets for water supply and drainage in Vietnam has been achieved as following. Regarding cleaning water supply, in urban areas, the total capacity of clean water supply reaches 11 million cubic meter per day, which increased by 4 million cubic meter per day compared to 2015. The rate of water supply reached 89%, which increased by 8% compared to 2015. The rate of physical and financial water loss decreased to 19%, which decreased by 5.5% compared to 2015. In rural area, the percentage of people accessing to hygiene water is 88.5%, which increased by 3.5% compared to 2015. There are 4 regions reaching more than 90%, which are the Red River Delta, the South Central Coast, the Southeast, and the Mekong River Delta. Regarding drainage and domestic wastewater treatment, the total wastewater treatment capacity is about 1,180,000 cubic meter per day. The treatment rate is 14 to 15%, which increasing 4% compared to 2015, mostly in urban area. Ladies and gentlemen, although many positive results has been achieved, Vietnam's water industry still have many difficulties, especially the big challenges to face, such as first, the increase of urban population. Second, the urban planning solution. The water supply and drainage infrastructure has not keep up with the urban development speed. Third, the extreme effect of climate change like drought, flooding in urban area, seawater intrusion or landslides, and so on. And fourth, it is about the limited budget, the lack of operational management capacity, the mechanism and the policy to attract investment in water supply and drainage infrastructure, especially in the field of urban drainage and wastewater treatment.
Trước những khó khăn, thách thức đã đặt ra của ngành nước Việt Nam để hướng tới cái tương lai sạch và xanh, giải pháp ưu tiên sáng tạo để phát triển cho đô thị thì chúng tôi thấy tập trung vào những việc thứ nhất là nghiên cứu các giải pháp an ninh an toàn nguồn nước đa mục tiêu, ứng phó biến đổi khí hậu, xâm nhập mặn, đặc biệt là trong vùng đồng bằng sông Cửu Long. Thứ hai là tổ chức thực hiện các chương trình cấp nước an toàn theo cái quyết định số 1566 của Thủ tướng Chính phủ ngày 9 tháng 8 năm 2016 về vấn đề chương trình quốc gia đảm bảo cấp nước an toàn giai đoạn năm 2016-2025. Đẩy mạnh việc áp dụng các khoa học kỹ thuật, tiến bộ khoa học kỹ thuật và các giải pháp sáng tạo, tái sử dụng nước, tăng cường mảng xanh, giống như các cái giải pháp đối với phát triển đô thị là các cái vùng lưu trữ nước trong đô thị được bổ cập vào nước ngầm như là diễn giả Frank vừa trình bày. Nghiên cứu các cái công nghệ mới trong xử lý nước mặn, nước lợ, ứng dụng công nghệ thông tin, kỹ thuật số trong quản lý, phân vùng tách mạng, SCADA, các công nghệ sinh học, tiết kiệm năng lượng, thu hút các nguồn lực cho việc đầu tư xây dựng ngành nước, nâng cao chất lượng nguồn nhân lực, trang thiết bị, tiên tiến hiệu quả, các cái trang thiết bị tiết kiệm vệ sinh. Tuy nhiên, mức độ tiếp cận sẵn sàng trong vấn đề quản lý cái công nghệ 4.0 thì vẫn còn rất hạn chế. Hội thảo tương lai sạch và xanh, giải pháp sáng tạo phát triển đô thị trong Việt Nam luôn làm cơ hội tuyệt vời cho ngành nước Việt Nam, cho các doanh nghiệp, cho hội viên hội cấp thoát nước được tiếp cận và học hỏi, nhận thức sâu sắc hơn về các giải pháp sáng tạo cho phát triển ngành nước nói chung và phát triển hạ tầng cấp thoát nước đô thị tại Việt Nam nói riêng. Những tác động mạnh mẽ của nó sẽ tác động đến việc quản trị, chiến lược phát triển ngành nước, phương thức cung ứng các dịch vụ về cấp thoát nước, từ đó để xác định được những thời cơ, thách thức trong tiến trình hội nhập với các hội nước quốc tế về ngành cấp thoát nước. Đặc biệt tại diễn đàn này thì chúng tôi được lắng nghe những bài học kinh nghiệm quý báu từ các diễn giả, các chuyên gia, các nhà quản lý nổi tiếng từ các tổ chức doanh nghiệp quốc tế. Hy vọng hội thảo ngày hôm nay sẽ mang lại những thông tin bổ ích, nhiều bài học kinh nghiệm quý báu cho ngành nước Việt Nam và các doanh nghiệp hội viên trong việc hòa nhập với xu thế sạch và xanh, sáng tạo trong phát triển hạ tầng cấp thoát nước đô thị.
In the context of these above-mentioned difficulties and challenges, to keep Vietnam water industry move towards to a clean and green future, we can see that some priority solutions are being implemented as following. First, carry out research on solutions to the security and safety of water sources and multi-purpose water sources to respond to climate change, seawater institution. Second, organize the implementation of the Safe Water Supply Program according to the decision number 1566, date August 9, 2016 of the Prime Minister approving the national program to ensure safe water supply for the period 2016 to 2025. Promote the application of scientific and technical advanced innovative water solutions such as reuse of water, enhancement of green areas, urban water storage area like we just listened, the sharing from Mr. Frank, groundwater recharge, and so on. Third, carry out research into new technologies in salt and brackish, water treatment, application of digital information technologies in management like SCADA, zoning, network separation, biotechnologies, energy saving, and so on. Fourth, attract resources in the construction of the water sector, improving the quality of human resources and equipment. For example, advanced and efficient equipment for water saving. However, the level of readiness, especially in the application of 4.0 revolution in the water industry, is still very limited. Therefore, today webinar, The Future is Blue and Green, is a great opportunity for Vietnam water industry, enterprise, and member of BWSA to approach, learn, and be more deeply aware of innovative water solutions for the development of water sector in general, and the development of urban wastewater infrastructure in Vietnam in particular, about its strong impact on the management of water resources, cooperate governance, water industry development strategy, production method, service provision, and so on. Thereby, people can identify opportunity and challenges in the process of integrating with international association and organization in the water supply industry. Especially at this webinar, we will listen to many valuable lessons from speakers who are expert and famous managers from international organization and enterprise. Hopefully today's webinar will bring a lot of useful information, many valuable lessons for Vietnam water industry and for VWSA members in integrating with the development trend of clean, green, and creative.
Nhân dịp hội thảo, tôi xin gửi lời hỏi thăm tới các diễn giả, các tổ chức quốc tế, các hiệp hội nước bạn đã tham gia và luôn luôn chia sẻ hỗ trợ cho ngành cấp thoát nước và Hội cấp thoát nước Việt Nam. Xin kính chúc các vị đại biểu, các quý khách cùng toàn thể hội thảo sức khỏe, hạnh phúc. Chúc hội thảo thành công tốt đẹp. Xin trân trọng cảm ơn. Thank you very much.
On the occasion of this webinar, I would like to send my sincere thanks to the speaker, international organization and association for always sharing and supporting Vietnam water and sewerage industry and VWSA. I wish all the leaders, distinguished guests, and all delegates health and happiness. Wish us a fruitful conference. Sincerely, thanks.
Thank you, bye for IWS.
Thank you. Thanks a lot, Dr. Tran, for sharing your view and highlighting again as well the importance of collaboration. As well, you shared some amazing achievements, improvements from 2015 to now, but you highlighted as well that there's still a lot of work to be done. So I hope and I trust that this webinar will maybe spark some new ideas. And I saw there were a lot of questions as well to you, so I hope you can stay with us until the coffee break, so we can address these questions.
Thank you.
Thank you.
Okay.
Now I would like actually give you some insights from a construction material supplier's point of view and address the question of green and grey infrastructure, whether this is a contradiction. So I will give this presentation with my hat on as EcoCycle and Sustainability Director of INSI Vietnam. And we have chosen this picture actually in here because we see very clearly the green part, right? We see the blue part, and now let's talk as well a little bit about the gray part. So we add an additional color to our discussion. So just for us to have a common understanding when we're talking about green infrastructure and gray infrastructure. So for us, green infrastructure is really referring to all the natural systems, the rainwater harvesting, wetlands, green roofs, rooftops, gardens, etc. On the other hand, we have the gray infrastructure, which, for example, includes the wastewater treatment plants, the flood mitigation berms, concrete walls, concrete seawalls, dams, etc. Now, the question is a little bit, do we need one or the other? Do we need only the green infrastructure? Do we need only the gray infrastructure? And actually, the conclusion, not only from us, but from many experts, is that we need both. We need to integrate the green and the gray infrastructure. So the green infrastructure is not a replacement for the gray infrastructure and vice versa. And a smart approach would actually to have a hybrid green-gray approach. So one that combines the green ecosystem and restoration with the gray conventional engineering. Doing this will actually generate more benefits as if we only would pursue one or the other strategy in there. Now, there is, of course, a little issue that has already been mentioned by Tommaso in his opening remarks, and this is about CO2, is about climate change. And of course, we know that due to the gray infrastructure, the CO2 emissions have been increased significantly over the last years. So we know as well that even in the future, there will be a lot of spending into gray infrastructure, into dams, into roads, into bridges, etc., etc. So we are talking about $93 trillion over the next 20 years. On the other hand, we know as well that about 70% of the emissions, global greenhouse gas emissions, are linked to carbon-intensive gray infrastructure, power plants, buildings, transportation, and the like. And third, we know as well that by 2030, double the amount of people will be impacted by floods. So floods will increase And I think this is specifically as well an important topic for Vietnam, because in terms of climate change, Vietnam will be suffering a lot. It is among the top impacted countries worldwide. So if the sea level rises by 1 meter, 39% of the Mekong Delta will be underwater. 10% of the Red River Delta will be underwater. 20% of Ho Chi Minh City will be underwater. So there's definitely no time to react on this. So now concrete and cement are actually the main materials for infrastructure projects. So after water, concrete is the most widely used substance in the world. And this is because of his specific characteristics. It has a long lifespan, it has a high strength, it is low cost, and it's rather flexible because it can be shaped and sculpted into anything you can imagine. Now, the problem is, again, that the production of clinker and cement releases CO2 emissions. And you see about 50% of the CO2 emissions is coming purely from the materials, from the process itself. And only 50% of the rest is linked to burning fuels and indirect emissions in there. So there is a global trend to go towards blended cements, and this will really reduce drastically the global warming, and it will support sustainable development.
Hội thảo này về ngập úng đô thị của phía Nam và Việt Nam. Cái này chúng nói cả ngày không hết, mỗi tội không biết tiếng Anh.
Sorry, can you mute yourself if you're not speaking? Otherwise, it's getting a bit. Give me a second, I will try to. Okay, let me mute all. Good, sorry for that. Let me try to go back to the presentation now. Okay, good. So there's a big trend into blended cement. So what we are trying to do is to reduce basically the clinker in it, and increase other substitutes in it. So this will have a big impact into reduction of CO2 emissions. So to give you a benchmark, so in the European Union, cement clinker has around 760 to 800 kilograms of CO2 per clinker, a ton of clinker. So if we can now create products which have a lower clinker content in it, but has a higher content of other materials, of recycled materials, of byproducts from other industries, we can reduce the production in CO2 emissions drastically. As you see here in the graph on the bottom right, a normal clinker cement generates, as I said, around 800 kilogram CO2 per ton. And if we are using a blended cement with a high recycled content, we can reduce this by close to 54% in it. And there is a clear trend in Europe towards these composite cements, these blended cements. And you see as well, over time, this is going down drastically for the OPC cement. So we expect a similar trend as well in Asia, in Vietnam, in here. So in Vietnam, this blended cement has quite a lot of tradition. It's able to adapt to the local tropical climate. It's as well efficient in terms of clinker availability. However, what we see as well a bit over the last years, that the utilization of Portland cement, so high clinker cement, actually increased. And this is mainly driven because of project specifications that came from US and Japan, and they are one-to-one implemented in here without considering the local situation here. So it's a copy-paste specifications. So I think what we have to promote more is to say, how can we increase and support more blended cements in here, because that's definitely the preferred solution for sustainable construction. Before I go into concrete applications on how we support the grey infrastructure related to water management, maybe a few other green manufacturing aspects of INSI Vietnam. So we are having our waste heat recovery system. So we are generating about 25% of our electricity from our own waste heat. We are in the process of a solar energy feasibility study to generate an additional 17 megawatt of electricity. We are using a lot of waste-derived fuels instead of fossil fuels. So more than 25% of our thermal energy comes from waste-derived materials. And we are having the Singapore Green Building Council labels as leader, excellent and very good for all our products. And we are actually right now in the process to have our own EPD for the project. So an environmental product declaration for all our products. These are our products that we are having here in Vietnam. So we are offering only blended cements with a lower clinker factor. We are offering products which are specific to the application. And I will talk a little bit later on what are these applications. One more product as well that I would like to highlight in here is a conwood, which looks like wood but has the characteristics of concrete. So it's very durable, but it looks nice. It has a high recycled content material, about 25%, but as I said, is still very strong, durable, like concrete over the time. So how can our innovative cement and concrete solutions actually support the urban development, water security, and increase the climate resilience of the projects? So basically here you see all the potential aspects where our products, blended cements, can be used. Of course, in buildings, in wastewater treatment plants, in hydropower plants, airports, roads, metro lines, refineries, thermal power plants, so all industrial applications as well. So to give you two examples, so one about a solution for a wastewater treatment plant, and you see here basically for each application we have a specific product that is addressing the needs of that application. So we have INSI Extra Durable, which is a sulfate-resistant cement. This is extremely important, especially when we are operating in salt water or in regions where this is becoming an issue. We are having our own products for soil treatment cement, ISS, for cement deep mixing applications in here, for foundations, pilings as well. So we can really offer the right product for the right application. So as an example here, this is a water environment improvement project in Ho Chi Minh City over the last 5 years. So you see here, this is a big work, a lot of gray infrastructure in order to support the the blue infrastructure long term. So we were one of the suppliers of our products for that application. Then, of course, and we have seen some hints on that as well in Frank's presentation, it's important to design and implement roads and canals appropriately. So here as well, we are having dedicated projects and products for that, be it in prefabricated products, in piles, in pipes, etc. We can provide our products to meet the needs of our clients in there. Here as well, this was a project a little bit back in time unfortunately, in Ho Chi Minh as well, where we helped with the environmental sanitation project in New Loc and Tine Basin. Now, there are other solutions we can offer is on wind power plants. So we are providing our products to Travin Baclieu, to the windmill plant in there. And then I think this is the last product I would like to briefly introduce. This is Hydropath. So that is a water permeable concrete. I think Frank showed this as well as one of the solutions. So there are a few applications already here in Ho Chi Minh and in Hanoi where this is implemented. So this is basically really a concrete that helps that the water can go through easily and drain easily away on it. So as a conclusion, I would like to highlight maybe 3 things. So first, we have to integrate the green and the gray infrastructure. It has clear benefits. Only together we can provide innovative solutions. We can provide water security and as well increase our climate resilience. And this is really an increasingly important topic for Vietnam. Then construction materials for this grey infrastructure with a lower environmental footprints are largely available in Vietnam. And we are talking about blended cements and application-specific products. So they can really support as well as sustainable and low carbon footprint grey infrastructure. And we here at INSEE Vietnam, our motto, our theme is we build for life. So I trust that our expertise and our experience can offer a lot for a built environment that is ready for the future and that can again support water security and make us here in Vietnam more climate resilient. Thanks a lot for your attention on this. And now I would like actually to move at least virtually to Australia. So Mr. Steve Dennis, who is the Chief Engineer at Advanced Enviroseptic, recorded his presentation about on-site wastewater solutions to address climate change and community development. But we have his colleague in the forum here, Mr. James Rose, and he will introduce us to the topic briefly. Please, James, if you can go ahead.
Good evening to everybody. I'm not sure what time it is where you are, but it's around about dinner time here in Australia. So if my stomach starts rumbling, I'm deferring dinner for this conference, so please excuse. Yeah, so I'm sort of just introducing Steve's video presentation, which is a slide presentation, because he's away on holidays, lucky him. And just by way of doing that, I thought I just might sort of introduce and speak about why I got interested in this product in the advanced enviroseptic systems. I'm a consultant, not an employee with advanced enviroseptic, and as I said, I just wanted to introduce why I got on board with this technology. Now, I don't come from a wastewater background or an engineering background. I'm not a technical person. Most of the work that I've done over the last few decades has been in sort of social rights areas, human rights areas, social justice areas, development areas and things like that, working in areas such as corporate ethics, socially responsible investing, and doing sort of media work as well for various people. So when I came to this, when I started working with AES, with Advanced Enviroseptic, which has an office here in Australia in Noosa Heads, which is a lovely beach area, if any of you are familiar with it, good surf and so on. When I first saw it, they brought me into on a communications contract, and I sort of had a look at the systems, and with my background and so on, I could see that how well it applied to many developmental contexts that I was familiar with. Given that I had some background in the Asia Pacific region and so on, and had some contacts there, I reached out to a few colleagues and so on, and did a bit of research and found a few new contacts and started asking around about whether my thoughts about how this technology would apply in the region were sort of valid, and it came back to me very much that they were. So I've become sort of pretty convinced that advanced enviroseptics, from my point of view, from a social justice and community development sort of point of view, has some very significant application in the Asia Pacific region, and I'm really interested to see a lot of what's been said about what's going on at the moment in Southeast Asia and in Vietnam and specifically. I see a lot of, I mean, as I say, I'm not a technical person, so I sort of see these things through a slightly different lens, but I see a lot of application areas where this sort of product might be possible. And to my understanding, it's not very widely used and not widely understood in many areas of Asia. So the fact that the technology doesn't use electricity and so it doesn't tie its users to power fees and electricity fees, it doesn't use chemicals, so there's no sort of ongoing cost once again. You know, suggests to me that this is a really useful application in many development contexts. Other positives are that it vastly reduces that really troublesome issue of septic disposal, which is obviously such a big problem all over Asia. Vastly reduces that through the treatment system it uses. And really the clincher for me is that there's a lot of capacity building built into this. That this is something that can be more or less self-maintained and run at community level, that doesn't need a vast amount of input from outside to keep it going. And already, as I've said, there's no power costs, chemical costs, all this sort of thing. So there's a real sense of legacy that you're embedding in this. There's a sense of empowerment for communities and so on. So really, when I think of AES systems, I'm thinking of, you know, real community development ideas. I see families being able to be safe and secure in their environments. I see girls being able to go to schools because there's a safe and secure sanitation set up there and so on. So with all of that, and being aware that there may be well questions around this, the presentation itself is a little bit technical. But if you're wanting to find out more technically about what's going on with the system and what we're talking about, I would suggest you email that address that's up on your screen there, and I can check with the technical people and get back to you quickly. Steve will be away for a couple of weeks still, so it's probably easier to do that. And rather than sort of throw technical questions at me here and let me embarrass myself in front of everybody and waste everybody's time trying to answer questions that I probably can't, maybe that's the best course. So with that, I will throw over to the video presentation. Bruno, I hope you've got that queued up okay.
Yes, let's try. I hope you can hear it.
This is my
I'll be here in case anybody wants to speak about it.
Engineer at Shankar Environmental, who are the agents for the Advanced Enviroseptic System, passive treatment system for Australia and New Zealand. So basically, we're here to talk about an on-site. Let's get rid of that. An on-site wastewater management treatment solution to assist with climate change and community development issues in Asia Pacific. Let's see how this goes. Okay, so the benefits of an AES system: get a very high quality output, very clean treated wastewater to advanced secondary treatment. Biochemical oxygen demand and total suspended soil levels are very low. And you get a very high dissolved oxygen in the treated wastewater. Climate change resilient, so again, completely 100% underground, requiring no electricity. The AES system can work through cyclones and bushfires and natural disasters. And it's a very low lifetime cost saving. It's very high lifetime cost saving, sorry. So you really don't need much other than a standard septic pump out every 3 to 5 years, and that's pretty much what you have to do. Okay. So the AES system has been tested all over the world, including the USA, Canada, the European Union, Australia, New Zealand. These ones are from the USA. So BOD levels were 8 and TSS were 4, total suspended soil 4. You can see the difference between the basic standard septic tank and what comes out of the AES. So the AES addresses several problem areas. So it's pretty robust. You can go on vacation or holidays. When you come back, it'll be working straight away, pretty much. It can handle, loading, high loads. So you can have a party on. Generally speaking, it can handle it. So no need for maintenance. Again, fully self-contained. No chemicals and mechanical devices. And communities can use them to build one system for several places. So the AES system wastewater treatment quality for BOD is 8 in Australia. The 10 milligram per litre is the 90th percentile, and then every test has to be under 20. And likewise for suspended solids, again, both easily meet that. The AES system uses differential venting has a high vent, which sucks air through the low vent. Minimum of 3 meters differential, goes up through the treatment pipes, then out through the septic tank, and then out the high vent. Most of the systems that we do, the high vent is on the house. This particular example just shows that we can remotely locate the low and the high vents. The advantages of the pipe is it's completely passive. Certainly treats very well and disperses into the surrounding grounds. No mechanical devices, electricity or chemicals. Durable, non-degradable, biodegradable components, and they last indefinitely. So yeah, there's again just a typical example of the what the AES looks like in there. So the AES cycles up and down a bit like a washing machine. So you get levels of liquid rise, and then they fall depending on what's going down the drain. And that gives anaerobic areas and aerobic areas, so you get different treatment in both of those. And as the liquid level drops, you can see there just a small amount of liquid left in the bottom. Again, that would be anaerobic, and the rest, in this particular case, would be aerobic. So it flicks between the two. So the question's been asked, which was a very good question, is do we get a sludge build-up in the AES treatment pipes? We don't, but I didn't know the answer, so that's a pretty good question. Basically, this photo here was taken after 4 years of operation. You can see down the bottom there, very little build-up of sludge. That's because it's alternating between anaerobic and aerobic. The anaerobic creates a sludge layer, or sorry, a biomat, and then the aerobic treatment removes that, so it continually fluctuates up and down. So the AES is good for urban spaces, suburban spaces, commercial. Done a lot of commercial systems. In the States, they've done at least up to 200,000 litres a day, probably more. It's good for rural and regional areas. We have done them on little blocks of land. We have done them on big blocks as well. Certainly handles fluctuations in flow, so you can get typical household don't constantly put down liquid at a certain rate at certain times of the day. So this one here is a typical Aussie home, 3 bedroom, 5 people. In Australia, that'd be 750 litres per day. I just assumed a clay soil for the size of it. That particular example, that's the size of the treatment bed would be. We'd need 10 pipes. Treating to advanced secondary, standard septic tank, no grease trap, and the high vent will be on the house. So this was an actual system we put in for a day use area at an Australian national park. Almost 4,000 litres per day, 10,000 litre septic tank. Split it through a distribution box into 2 treatment beds there. And it dissipates into the surrounding soil. Here's some examples of number 3 is that national park that I just mentioned that's being built. The first one there, that's a commercial install in Queensland. The number 2 one is a roadhouse or a service centre, again in Queensland, 20,000 litres per day. Again, this looks like a footy field. Number 4 is a large site. It's after it's been finished and served. Number 6 is a finished system for the domestic, which you wouldn't even know is there. So they blend fairly well into the background. This is what a small one-person system would look like, 150 litres per day. It's 2 pipes in a straight line in this particular example. And we've got a straight raised connector in because we must have a minimum of 2 rows. And that's what the cross-section of that particular example would look like. This would be a typical 5-person house, 750 litres per day, 10 pipes. Again, fairly clay soil in this particular example. In this particular example, we've used 2 rows, but we could have multiple rows and change the shape of the bed and multiple beds. There's numerous, infinite combinations, depending on your site-specific issues. This example here is a 150,000 litre per day system, equivalent of about 1,000 people. This one was set up into 5 separate treatment beds, so that as the development progressed, they can add treatment pipes in, so you're not up for the total huge cost for a big, huge treatment plant if you're not using it until you need to use it. Okay, so recapping, the Aes system can certainly solve many wastewater problems. Common to the APAC region. It's used all over the world. There's well over 400,000 systems in the world, about 5,000 in Australia and over 1,000 in New Zealand. So certainly sustainable and certainly cost effective, especially if you look at your lifetime costs. Again, no electricity, no chemicals. Chlorine can be a fairly dangerous chemical, can actually kill the soil. No maintenance other than a standard septic pump out. All of those issues you get with your standard aerated wastewater treatment systems. So it's got a lot of community benefits, especially if people want to get together and put in a common system. A lot of environmental plus points. Certainly tried and tested technology with full support, and it's been invented in 1995, and that particular system that he did his trials on is still working. And it certainly meets a lot of your sustainable development goals. So thank you for that. I hope you enjoy your seminars. I'm still on leave, but my email address is at the bottom of the screen. If anyone's got any questions, I'm happy to try and answer them. And yeah, thank you.
Good. So that was the presentation pre-recorded by Steve, but we have as well James here. So if you have any questions, you can still ask, or as James said later on, there's still possibility to ask the questions via email. So you have the contact details. Now we are basically at the end of the first part of the presentation, and now let me go as well into this mode here. So we received a lot of questions on our chat. I think I will maybe choose 2 or 3 to answer here, and the rest we will make sure that the respective presenter will answer it later on in a summary email. So let me check, is Ms. Haller from World Bank still with us?
Yes, I'm still here. Yes.
Perfect. There was a question for you, Ms. Haller.
Yes.
Is this project, the Duongdong Wetland Park, financed by prospective tourism expense? And if yes, is COVID changing any plans for the financing?
So thanks so much for the question. It's a very good one. I just wanted to reiterate that these are actually conceptual phase designs, and have not have not actually been adopted yet, we should say, and are not being implemented yet. So these are ongoing discussions that we're having with this one was about which one? The
Duongdong Wetland Park. Sorry.
Duongdong. Yeah, these are ongoing discussions that we're having with government. We have in both cases of the Phu Quoc and the Ho Chi Minh, we have either pipeline or ongoing bank operations that could incorporate these initiatives, but they haven't been adopted yet. So it's an ongoing discussion that we're having with government, and we're hoping that these sort of I would say innovative really solutions are something that they will want to take forward. So neither of the two are underway at this point, but we're in intensive discussions with government on adopting them. I hope that answers the question.
Thank you. Yes, thank you. Then there was a question to Dr. Tuan from the association, Vietnam Water and Sewerage Association. And so maybe I raised the question in English, and Trang, if you can translate. So is the price of processing water not a major issue to private sector operation in the water sector?
Anh Tuấn ơi, bên các quý vị khán giả thì có một câu hỏi cho anh ạ. Câu hỏi là liệu giá nước thì có phải là một vấn đề chính đối với các hoạt động của khu vực tư nhân trong lĩnh vực nước hay không? Anh Tuấn ơi, anh mở mic lên anh nhé.
Hello.
Dạ được rồi ạ.
Hiện nay thì ở Việt Nam ấy thì cái giá nước sạch ấy cấp được quy định ở cái thông tư 75 ban hành từ năm 2012 là thông tư về hướng dẫn và nguyên tắc phương pháp định giá và thẩm định quyết định giá. Thì cái giá nước sạch ở trong đô thị phục vụ cho sinh hoạt và các cái khu công nghiệp ấy, các cái dịch vụ khác ấy, thì được quy định ở trong cái thông tư 75 này, là thông tư liên bộ giữa Bộ Tài chính, Bộ Xây dựng, Bộ Nông nghiệp Phát triển Nông thôn. Tuy nhiên thì hiện nay Bộ Tài chính đang soạn thảo cái thông tư này thay thế cho thông tư 75. Thì cơ bản thì vẫn là doanh nghiệp và sản xuất nước ấy, người ta đưa ra các cái chi phí, nghĩa là tính đúng tính đủ và hợp lý. Thì trình cho Ủy ban Nhân dân tỉnh là cấp tỉnh ở cái nơi mà được cung cấp nước ấy, người ta sẽ quyết định phê duyệt cái giá ấy. Và trong cái quá trình đầu tư xây dựng của các cái doanh nghiệp cấp nước thì người ta cũng cái dự án được phê duyệt thì nó sẽ có các cái lộ trình tăng giá, thì cũng trình với Ủy ban Nhân dân cấp tỉnh, người ta sẽ phê duyệt giá nước này. Thế còn bây giờ thì chưa có thông tư mới, vẫn sử dụng thông tư 75, nhưng mà theo kế hoạch thì năm 2021 này sẽ ban hành cái thông tư mới. Chúng tôi cũng đã đóng góp ý kiến với Bộ Tài chính về cái thảo cái thông tư mới này rồi, và các cái doanh nghiệp cấp nước thì cũng được tham gia góp ý trước khi Bộ Tài chính sẽ ban hành.
Okay. Regarding the water price, you can have a look at the circular number 75, which were issued on 2012. To have more information, that circular were prepared by Ministry of Finance and Ministry of Construction, and it states clearly about the price of the water. So far, for my understanding, if any enterprise or company who want to do business with water, first they have to have a plan. They have some calculation about the price of the water they want to sell to the people. And then they submit that plan to the local authority and wait for the approval from local authorities. And and in that plan should also clearly state the selling price. They want to sell the water out, and the plan to increase the price over the year during their operations. And if they get the approval from the local authorities, so they can continue with the plan that they submitted before. That is based on the circular number 75 data from 2020. But as far as I know, in this year, 2021, a new circular will be drafted and be published soon. I also were asked to give the consultancy on drafting the new circular.
Okay, thank you very much on this. I suggest we take one more question here in the forum, and this is to James on the advanced enviroseptic presentation. 3 small questions in there. So how much does one small project cost? How long does it last? And is there any bad smell produced out of the aeration pipes?
Okay, not too technical. I think I can handle those. The cost varies, so I can't offer a definitive answer on that because it varies on soil type, water flow, daily flow, and things like that. So basically, we need to get a sense of what the water flow is and what the soil type is, as how I understand is the basics that are required to offer a costing on something. So I can't really help with that. If you want to go to the website, the AES Advanced Enviroseptic website, which is advancedenviroseptic.com.au, there may be some pricing guidelines on there, I think. But if you want to email me with any ideas for things that you'd be thinking of doing, I can give you sort of a ballpark quote after speaking to the technical people. Sorry, I can't be more definitive on that, but it is a bit of a variable cost.
Yeah.
To approach the other ones, as far as I know, they last indefinitely. I think Steve made the point that the model that was first put up for this product, this technology, was first laid down in 1995, and that's still running. So what's that? We're looking at almost 30 years ago. So it should last indefinitely. The materials, there's a lot of recycled plastics and so on in the materials. So there's no reason that they would deteriorate. In somebody's lifetime, for instance, and that seems to be, I mean, the systems have been going for decades already. Insofar as smell, there is no smell. The smell is pretty much contained, so no bad smell. So that's a simple answer.
Okay,
Thanks.
Very good. Thanks a lot. There was one other question I will take because I can answer this very briefly. Yes, all the presentations will be made available. So we asked all the presenters for their agreement. So we will share this with all of you after the event. For the ones from whom we don't yet have the email address, please provide it to us. And now what I suggest is maybe before we go into the break, now we will have a 15 minutes break. Could we have everyone turning on the camera? And then we can make a little screenshot so that we can include this as well into the package material that we will share with all of you afterwards. Yeah. So it's it's a difficult time, right? We cannot meet physically. That was the initial idea. So at least having all these faces on the screen gives us a little bit the impression, yes, we are together and we are not just talking to a screen. We are actually talking to people. So thanks a lot. So Trang, if you can help us with a screenshot. Yes, very good. All done. So now we basically have just a 10 minutes break to refill the water glass and maybe stretch a little bit. During this 15 minutes, we will screen a video from our sponsor, ATP Water, and then we will be back in 15 minutes from now. I don't say the time because we have people in Europe, in Australia, and Vietnam, so the time will be different. Just please be back in 15 minutes, huh? Super. Thank you.
Thank you.
See you. And I will show now the video, huh? So for the ones who are interested. Okay, very good. I see we get some email addresses to share the presentations afterwards. Perfect. I hope you had a refreshing, quick break and that you're ready for the second part of our webinar. And for this, I would like to get started with Suresh Kumar from Inteva.
Yes,
so the title of his presentation is Stormwater and Greywater Treatment and Reuse in Buildings, State of the Art. So Suresh, do you want me to share the screen or do you do it from your side?
yes, you can do it. You can help me by showing us the presentation. Would be great.
Okay. There we go. And then put this down.
Perfect. Yes,
Then
that's
you're good to
fine.
go.
Yes, thank you very much for the time, Bruno, and also for Water Hub and all the stakeholders who inviting Intewa for this event. Yes, my name is Suresh Kumar from Company Intewa in Germany, correct? Yes, we are founded in 1993 in Aachen, Germany, and we develop and distribute products and systems in the areas of stormwater management, including rainwater infiltration and attenuation, will be also our topic today, as well in water treatment and reuse, including, for example, drinking water to potable water, rainwater to potable water, grey water treatment, and also the effluent of wastewater treatment is possible to treat to non-potable water. Okay, next. Yes, maybe grey water recycling is quite new, but not really new. That's why I would like to explain briefly about what is a grey water. This is the water coming from showering, bathing, washing hands, and washing machine that has a very less BOD, less than 180 milligram per liter. And normally we use this treated grey water for toilet flushing, washing machine, or general cleaning and irrigation. For further application is also, for example, for cooling tower is also possible. And next, yes, let's see what is the benefit by using or recycling the grey water. First, you save on both potable water costs as well wastewater costs, and also, of course, you are be independent of fluctuating drinking water and wastewater charge in your country. And depending on local water charge, this make your projects or the system has a payback period less than 5 years. And also, this is also to increase the value of the property you have, and we call it sustainable investment, and market your building as green, for example. And of course, you need a smaller space needs because you produce every day grey water and then you treat it every day and use it again every day. So very compact system. I will show you how the system looks like. Maybe next. Yes, correct. This is the patented Aqualoop, we call it, membrane system. This is the heart of our water treatment system. We use this membrane for drinking water production as well from rainwater and also for this grey water system. And for grey water, we have a system package solution including tanks and pre-mounted from 200 liter per day up to 100 cubic meter per day. And at the moment, we are the only company worldwide having this certification, NSF 350 Class C, means a commercial. And the system is adaptable and expandable system because as you see here, the system, we can put more membrane cartridge in one membrane station. So in the future, you can expand the system regarding to the situation. And we are working here with ultrafiltration with hollow fibers. It retains bacteria and viruses. So you also don't need the advanced chemical additive as disinfection because this ultrafiltration also works as a final disinfection because these chemical additives such as chlorine is harmful. Correct. This is, for example, our one family house system for 300 liter per day capacity, for example, 5 to 6 people equivalent with using 2 350 liters tanks. First tank on the left side as our bioreactor tanks and the right side as the treated grey water. This is a very compact. you can install it in the basement or in the garage or in installation room, of most domestic houses due to this small space requirement. I also have next, Bruno. I also have the bigger system for commercial. The principle, I will not explain you how it works, the biological system and the details process system because of the time. I want to say also only briefly, on the left side, this is also bioreactor tanks. You see, we put the membrane filtration and also the biological degradation take place in the left tanks, and the right side is the clean water tank. And for commercial system, we also we offer complete system pre-mounted with indoor tanks and with automatic cleaning, membrane cleaning in place. So it clean the membrane. For example, we program it once a week or whatever we want. And important with this our new new system, we offer with iConnect monitoring. This is to enable full remote access to the plants via, for example, web application or through your mobile phone, that you possible to monitor and control the system wherever you are. And also this enable to see the plan in the statistics, so you can optimize the plant operation through the data evaluation. And I have some references, the system we have installed. At the moment, we have 200 systems installed worldwide, and I would show you, for example, 2 references that we have. For example, this is the guest house camping or camping in the Tyrol camping ground. This capacity 5,400 liters per day, using water from showers and hand wash basin in purpose for flushing toilets, and including also automatic chemical cleaning in place. So it's a package solution we sold, including indoor tanks. And also the second reference, we have also have the system installed in Sport Center in Los Angeles, US. This they collect the grey water from shower as well and wash basin, and using for flushing toilet as well for irrigation. Yes, as I mentioned in the beginning, besides the grey water system, we developed also system in stormwater management area, like for infiltration and retention trench system that very useful in country, for example, in Southeast Asia country with a very high rainfall even. And with these tunnels, we claim this is the best price per cubic meter due to the geometry of these tunnels. We required only minimum transport volume because it's you can see in the truck it is stackable, and we need only minimum space requirement. And another side, it has a huge storage volume, about 1.6 cubic meter per tunnel. You can store water underground. So that's why we say it's the best price per cubic meter. And this is made in German. We have, we call it DIBT certified. So we have extremely stable and loading class up to 60 tons. And this is also easy for installation. You can carry it only for 2 people due to the weight. Yes, okay, the picture come later. And also the bottom of the system is also washable for the maintenance purpose. This is the first system installation schematic for example, for stormwater infiltration. Just in case if the soil is capable of infiltration. So this has become essential in new construction and also in the area for, with excess rainfall even. The system consists of a pre-filtration pit. You can see in the left side, and the middle is the tunnel itself, and the right side is the control pit. So first, the rainwater coming to the tunnels is purified through sedimentation or pre-filtration pit, and this also acts as sedimentation pit, and we can draw out the sludge frequently from this pre-filtration pit. In case you are collecting rainwater from the street inlet, so we also have the pre-filtration to minimize or to treat these heavy metals containing in the street rainwater inlet. And you can also above these tunnels, you can also use it such as for access road or parking space because of the heavy loads up to 60 tons. Yes, I have this reference. This is in service logistic park in Augsburg in Germany with a total storage volume of 860 cubic meter water stored underground in the tunnel, and then it getting infiltrated on site in heavy rainfall events. Yes, another system that we have in case if your soil or if rainwater cannot or may not be infiltrated on site, so we need to store it temporarily. So we can discharge in a throttle manner to prevent overloading in our drainage system and lead to flooding. This is the same system as infiltration system, but at the right side you see this is a throttle pit where we discharge the stored water in the tunnel with some flow rate. So the system also included the pre-treatment and also sedimentation pit as well, this throttle pit for the control pit. Yes, I think yes, this is also reference from a cultist breaking a lot in Oberkochen, Germany, with rainwater collected vaping from approximately 5,000 quadrat meter gravel and rainfall collected in the tunnel with the capacity of volume of 138 cubic meter. And this system has been built on ground area only about 250 square meter. Yes, I think that was a very short presentation or information from our greywater recycling system and stormwater management for infiltration and retention system. I give it back to Bruno. If maybe there is a question, I will also check our chat windows and answer your question. Thank you very much for the time, and I give back to Bruno.
Excellent, excellent. Thank you, Suresh, for this interesting elaboration on greywater and stormwater management. And yes, definitely, if there will be questions, either we will answer it today or we will let you know about the question so we can answer it afterwards. Thanks a lot.
Sure.
Yeah.
No problem.
Then I think we move on to the next presentation. Sorry, I missed one picture here. But let's move on to the next presentation, which will be conducted by two gentlemen, I assume. So let me try to get the names correctly. Mr. Olivier Souquet and Mr. Martin Jalenelia. They are working for Deso Architect Urbanists here in Ho Chi Minh City, and they will talk about the water in urban landscapes as an important element in urban planning. So, gentlemen, do you want to run the show from your screen? Okay, so
I am Olivier Souquet, and Martin cannot be assist to the conference, so I will be alone. You heard me? It's okay. Can you share your screen, Bruno, please?
Okay, so I will share. Good. Yes, I can do that. Back to this. I hope you can see.
So, yes, I see. Deso is a French company based in Vietnam since more than 10 years. We work on planning, and I am architect, and as we work on planning, sure, in Vietnam, the question of water is everywhere. We work also in mountain, in the north of Vietnam, and we work also in wetland area, and always this question of water is everywhere. Next. Our company have done many projects, so I will speak about the big scale. The scale of the city. Here it's Ho Chi Minh City, where we can see the blue frame. Water is everywhere. I will present shortly three projects next, and sure, in Vietnam, what is absolutely fantastic. It is always that the farmer organize their land. This is a picture. So three projects next, and the importance of the water on the city. This is in Morocco. Next, this is in Paris. This is in New York. The water and the river along with embankment create a huge and beautiful landscape in city. Why in Vietnam we cannot catch this opportunity? Next. So we are responsible of a very big project. This project is a two-team area. We win the competition 12 years before. We do actually the basic design. And we have won this competition because we create a park. We create a park with permeable area. This park can accept water of the city. It can accept the shadow of the tree, and this is very important in the city to have such area who can accept a different type of water. Next. We are front of District 1, and the strategy for this project next is to try to collect some water, rainwater of the district, and to collect it in a basin. This was the first idea, but it was very difficult to do. And also the second reason why we do this project is that this project can accept flooding in the city, flooding in Ho Chi Minh City. And this is very important that some space in Ho Chi Minh City can accept flooding, especially some public space. Next. This project accepts a different type of water, and as a planner, I play with different strategy. For example, when it's raining, we obtain more and more water on this area. Next. And this area also accepts a lot of basin who can collect the water. Second project, we have won 10 years before in Hanoi. Here, we have worked on the geography. How a project in Vietnam can have attention to the geographic of the river. Next, and in this area, it is in Zalam, near Hanoi. This is a site. We have a lot of water, and here we have many rice fields. And in fact, we have imagined a place where the land can accept, like a big water tank, the flooding of the city. This is a concept. The idea was to create, as we have also in Hanoi Lake in the city, a big water pond on the center where we have also altimetry very low, and we create water where all around we create different districts, different possibility to add different blocks. This is what I have on my screen. I remember 12 years before. And this is the project with, on the center, this very, very huge area who can accept a different level of water. And the water can be, in this project, the identity of the city. It means that we need to accept that water is on life, and this is something since 10 years I work in Vietnam, very difficult. Many times we want to hide the water, we don't want to see the water on the city. And in this project, we completely change the way we can observe the water next. And so this is the project we have. We can see the water stop. And the water creates here a huge opportunity to create a different, very nice waterfront, different type of program for different owner. Next. Also, we have in this project attention of green line and agriculture in the city. Next. Next. It's a very short presentation, so it's quite complex to explain what is a concept, but I would like to explain that as a planner, I use the water in Vietnam to create opportunities in our project. It is a strategy to develop architecture, to develop planning. Third project we have developed here. We don't win this competition, but it's important. It's in Da Nang. It's along Han River. Next. And the difficulties we have at this place is the city wants to create an attractive area along all this embankment. Next. And the strategy we try to develop was this one. The embankment can sometimes be in a strong mineral embankment and sometimes can be more smoothie, make with nature, small infiltration of nature. We don't want, in fact, in this project, we have developed different type of embankment where we have soft embankment and hard embankment. Next. And this was, in this project, the opportunity to develop different parks, different place where the nature in the city can be developed, a link with the water of the Han River. Next. Here you go, slowly. And what I would like to express here also, exactly like in 2 teams, let's stop, this picture is very important, is we try to define the maximum border and contact between water and land. We know that there is many scientific or technical way to do, but also on planning, we can do that. And everybody knows that the longer limit we have between water and land are important, and also the more contact we have when we are flooding or where we have rainwater flooding, it's very good to stop the water. Next, and this strategy also in the city can create a different possibility to create different place, very attractive place and very different. Also, as a planner and as an architect, we use some different strategy to better see the water on the city. Next. And the strategy is to absolutely stop this the idea that we have a strong embankment, and the idea was to see the water on the city. Next. Next. This one is very important. We use a lot of strategy, as also explained Mr. Pogad at the beginning. We have a lot of place where the nature in the city can collect the water along the street. With the big difficulties in Vietnam, that pollution of plastic thing and also the maintenance of this area are very difficult to do. This is a difficulty I have in 2 teams to create a green area on the city. Question of maintenance are very important. Next. And I think this is, I try to go very quickly because I know that we are late, but my target was to provide with many all of you that planners who are at the beginning of the project can have a strong impact and develop many strategies with green and blue line.
Excellent. Thank you very much, Mr. Duque, for your very interesting presentation, and as well this kind of mindset change that, okay, water is not our enemy, it's our friend. It should be part of our daily life. We just have to manage it properly. Very interesting. Thanks a lot. And I think, again, we went through the slides relatively quickly, but everything will be made available to all the participants. And if you want to have any follow-up question or so, I'm pretty sure that DESO architects will be happy to answer this. Good. Then, without further ado, we will go to the next presentation, which will be conducted by Mr. Le Chi from HST Systemtechnik in Germany. And if I understand well, you will run the show from your computer, correct?
Correct. Let me share my screen.
Yes, thank you. And so the topic will be HSR screen and IntelliSystems, the revolution of mass containment at overflow structures.
Yes. Can you see my screen now, Mr. Bruno?
It's coming, yes. Yeah, now it's there. You're good to go.
Thanks, Mr. Bruno, for your introduction. And hello, everyone. My name is Le Chi and I am the International Project Manager in HST Systemtechnik. So today I will introduce to you the two products from HST, HSR Screen and IntelliSystems. They are the latest mass containment technology from our company to prevent floating in the combined sewer overflow structures. Okay, let's move. Can you see my second slide?
Yes, slowly coming. I think it's, yes, now it's there.
Okay, good. Okay, so let's take a look at our company's profile. HST Systemtechnik was established in 1981, and since then, we have been developing, manufacturing, and installing key products in the water industry. Our products are categorized into two main groups. The first group is machinery and equipment, including all types of smart machines, such as self-acting wares and gates, and other mechanical equipment. The second group is IT and automation, and this group consists of management and automation software. For example, we have SCADA for real-time monitoring and remote control, or Kenio for asset management. Furthermore, we also offer various services to our customers, such as process design and training. In the recent years, the application of our products is focused on the combined sewer network, deep tunnel collector channel, stormwater retention tanks, SBR treatment technology, and so on. So with the application of IT solutions and smart machines, our technology brings various benefits to urban water management. So firstly, our solutions can enhance the resilience of the drainage and sewer network. Secondly, the combination of IT and smart machines also help us overcome the unforeseen events and constant changing conditions, which are usually caused by the climate change or insufficient information in the planning phases. Third, our technology can mitigate the discrepancies between the planning and actual situation. And finally, our products are developed in a systematic approach to minimize the investment, operation, and maintenance costs. And this graphic shows the structures for combined sewer overflow reduction, what we usually call retention tanks. This kind of structure plays a vital role to realize the benefits that I mentioned before. The retention tanks have two main functions. Firstly, these tanks can temporarily collect and store excessive sewage, combined wastewater and rainwater. Secondly, they pre-treat the collected water in case the emergency discharge is required. In the normal condition, waste and rainwater is collected in a combined channel, and then it is transferred and treated at the wastewater treatment plants. However, in some extreme occasions, such as the heavy or prolonged raining events, the incoming water exceeds the maximum possible load of the collector channel or the treatment capacity of the wastewater treatment plants, and the retention tanks are designed to handle this issue. There are two main types of tanks in the retention tank, the catch tank and the sedimentation tank. The catch tanks are used to store the sludge of the waste and rainwater, which is highly polluted. Therefore, the water has to be treated, especially at the treatment plants later after the raining events. On the other hand, the sedimentation tanks are used to either to store excessive water in a short time or to discharge the rainwater to the water bodies. For the water entering the sedimentation tank, a floating solids retention system is required to retreat the water and prevent the pollution from the solids. And moreover, floating solids retention systems are also commonly installed in emergency discharge points of the sewer network. To protect our water sources in the overflowing events, it is essential to have an innovative system to retain these solid pollutants effectively. So these photos demonstrate what an emergency discharge point look like when the water level exceeds the maximum loading capacity of the channel. The overflow will occur. In this photo, there is neither equipment nor machine to pre-treat the overflows, and therefore the water sources are polluted by different types of solid pollutants, such as plastic bags or papers, etc. And the attention of overflow management has been raised since 1950s, and the most simple form at that time was the fixed scum baffles. Nowadays, the state-of-the-art technology in mass containment has integrated sensors, actuators, and intelligent automation software into operations. And the HSR screen from HST can integrate these technologies seamlessly. So what is HSR screen? HSR screen is a horizontal or vertical installed bar screen with an intelligent control brake system. The screen is used to retain coastal and fine solids from rain and combined sewer overflows. Therefore, it can significantly contribute to active protection in receiving waters. The screen can be implemented in different types of structures, such as combined sewer overflow structures, rainwater reservoirs, or raw filters. As for IT software integration, there are various possibilities. For instance, for automated operation, the screen can be integrated with Hydromatic, IntelliScreen, or IntelliNet. To monitor and control the operation of the screen effectively, SCADA or telematic can be an option. And this graphic demonstrates the main function of HSR screen. On the left-hand side, a majority of floating solids are retained by the screen, and only the overflow, which has been mechanically pre-treated by the screen, can be discharged to the water bodies. The retained floating solids are later transferred to the wastewater treatment plant by the natural flow and the gravity. Furthermore, the stream can be installed horizontally in some specific situations. For example, when there is insufficient space for vertical installation, or when the customers want to take advantage of the whole surface of the stream for filtering. And this video shows how the stream works in the project in Hosenstamm in Germany. Let me run the video. Yeah. Okay. So on the left-hand side is the this is combined sewer overflow structures, and there are two parts.
So unfortunately, we don't see the video. Mr.
Can you see the video?
No.
No?
No, unfortunately not.
Okay.
I suggest if you can add maybe the link to the video to the
sure.
presentation, then we can share it with the participants. Yeah.
Yes. Okay. After that, I will send the link to the chat, and so that you can see the video later on. Okay. So if that's the case, I will skip this slide.
Because at the moment we still see the development history of mass containment technology.
Oh, really?
Yes.
Okay. One moment. Because I saw my screen.
Maybe you need to double check the Wi-Fi and so.
Just go ahead.
But the point is they are stopping at the very first line. So, okay. Can you see my slide now?
It is still this development history of mass containment technology.
Okay, so maybe I will stop share screen and then I will start again.
Yes, please try it. Yeah.
Then, okay. Open. Can you see my screen now?
It's coming. Yeah, it's coming. Something is happening. Takes a little bit of time. Still black. Okay, now it's HSR screen intelligent solution for overflow.
Yes, this is the slide after that slide. Okay, so I just flip through briefly into this again. So the screen HSR screen is a horizontal or vertically installed mass screen.
Yeah.
With intelligent control rack system. And the screen is used to retain coarser and fine solids from the rain and combined sewer overflow. And the screen can be implemented in different types of water structures, such as combined sewer overflow structures or rainwater reservoirs. And there are various possibilities of IT software integration with the screen. For example, if we want to automate the operation, we can integrate with Hydropath, IntelliScreen, or IntelliNet. If we want to monitor and control the screen, so we can telematic or SCADA can be an option. Okay. Can you see the next slide now? The HSR screen vertical installation.
No, it's still on slide number 7. Now it's changed. Now it changed. Yes.
Okay. So there's a timeline. Okay. So on This graphic demonstrates the main function of HSR stream. On the left-hand side, a majority of floating solids are retained by the stream, and only the overflow, which has been treated by the stream, can be discharged to the water bodies. And the floating solids which are retained will be transferred to the wastewater treatment plant by the natural flow and the gravity. Can you see this slide? The HSR stream horizontal vertical installation.
Not yet. Still vertical. Now it's okay. Yes, go ahead.
Okay, so the screen can be installed horizontally in some specific situations. For example, when there is insufficient space for vertical installation, or when our customers want to take advantage of the whole surface of the stream for filtering. Okay. Can you see the screen now?
Just black. Ah, yes, now I can see the screen, yes.
Let's skip it.
Okay.
It doesn't work.
I think it works.
Just go ahead.
Can you see the video is? Yeah, okay. So I will skip this slide because I think it's not working.
Yeah, I think you can just add the link and then people can watch it afterwards.
Yeah.
Just to see is a normal presentation.
Okay. So next, I will talk about the automation levels. There are different automation options for our customers depending on their needs. And on the basic level, the screen works based on the predetermined switch on and switch off points. So, for example, in the vertical installation, the lowest point is set as a switch on point. When the water level in the channel exceeds this point, it means overflow is going to occur and the screen starts working. And in the second level of the integration, IntelliScreen can control the screen with dynamic speeds based on some predefined parameters. The parameters can be the pollution or the water level, whose data is collected via the network of sensors in the channel. And at the highest level, the external factors outside the combined sewer, such as the precipitation data, are taken into the account to optimize the performance of the end result. For instance, after a long dry season, the first flush of the rainwater is highly polluted. So the screens can be adjusted to the maximum speed to retain the floating solids with the first water, waste and rainwater batches. And with these automation options, water operators can control the stream based on reliable information instead of traditional subjective assumptions. Okay. And this is the operation process of HSR stream at the highest automation level. NearWeb provides the reliable actual and forecast precipitation data, such as the intensity, time, and duration of the incoming raining events. IntelliStream enables the dynamic optimization of filter performance by controlling the filter cake and its cleaning speeds. And finally, IntelliNet is the mastermind of the network because it collects the data from different sources, analyze the data, and then operate the smart machines, not only the streams, but also other types of machines like wares or flow control devices to achieve the best scenario.
So Mr. Nip, it seems there's still some internet connection issue. We're still on slide number 11, and I think you already moved on. So there's a little bit of an issue on this. Maybe, and as well due to time, can you maybe go to the either conclusion or last slide, so that we then move on to the next.
Okay, so maybe later on I will share the presentation and then you can share to the audience later on.
Yes, definitely we will do. There were some, I think, due to the internet speed or whatever, it was always stuck on your end, so we couldn't really see it there.
Okay. Yeah.
Extremely sorry for this. For the others.
Yes.
But I think we have on the slide we have your contacts, and
yes.
As we said, we will share the presentation, so there is no information lost in that sense. Thank you, Mr. Nip.
Yeah, okay.
All right, then let's move to the next presentation, which will be done by, if I'm correct, by Dr. Paul Schausberger from Uniha Wassertechnologie GmbH. He will talk about Uniha blocks and innovative modular water treatment solutions. So may I hand over to Dr. Schausberger, please?
Thank you very much. Hello to everybody. I will try to present from my side, so let me try this.
Very good. Everybody else, please mute yourself so that we can concentrate on Mr. Schausberger's presentation. Thank you.
So I hope my screen is visible.
Good to go, yeah, we can see it.
Very good. So, yeah, thank you very much for the invitation to participate in this workshop and to present our company and our technologies. The topic is the future is green and blue, and I will try to highlight the connection of our work, of our products to this topic. So Uniha Wassertechnologie is a company in Austria, in Europe. We consider ourselves water technology experts who are designing and building water treatment plants to treat industrial water and industrial wastewater, seawater and brackish water, ground and surface water. Our company was founded a bit more than 40 years ago. We have 99% export quota, mainly working in Southeast Europe, Middle East, Asia, Africa. What we do is we do turnkey projects, sometimes even with financing, and all the steps you need for that. This starts with an early stage consulting, where we analyze the situation, what water is available, what is the product that is needed, followed by a design phase, an engineering phase, procurement, construction, installation, and erection, up to the start of plants and the training, which we consider a very important point of our work. To give you a better picture of what we do, some selected references. Here you can see a groundwater treatment in Serbia, where we are treating iron, manganese, turbidity, arsenic, which also is a big topic in some Asian countries. Or the second one in the lower part of the screen, a seawater desalination plant in Egypt, where we produce in one plant 12,000 cubic meters per day of drinking water out of seawater. In the next slide, you can see a project in Ghana. This is a river water treatment. In Ghana, like in many tropical areas, they have the problem of high turbidity under stormwater conditions. And in this plant, we treat this water to up to potable quality. In the lower part, you see another reference in Iran, where we supply the whole process water needed in a steel mill. Here we have another reference for seawater desalination in Cabo Verde. Right now we are extending this plant by another 50%. Or a project of ours in Sri Lanka, where we also treat surface water for potable purposes. In the context of this workshop, I want to highlight one of our products, which we call the UNIHA blocks. The UNIHA blocks is a prefabricated and modular water treatment plant. So the idea is one block is a standardized unit operation, which is built in seawater, in sea freight container dimensions. And out of these blocks, we then build the treatment plants. Depending on the local needs, on the requirements, we add several process steps, and this then creates the total plant. We have one plant types ready-made, I would say, but I will speak about this a bit later. So which blocks are available right now? We have aeration, coagulation, flocculation, DAF, dissolved air flotation, media filtration, ultrafiltration, membrane bioreactors, reverse osmosis, and then of course we customize pumping stations and tanks. Also, all of these blocks in container shape, which allows easy transportation, which allows prefabrication, and then in the end, installation on site on a plug-and-play basis. So the first plant type we created out of these blocks is our so-called surface water block. So this is exactly what we did in Ghana, the reference we showed before. This is a plant which converts surface water, or let's be more precise, river water with elevated turbidity up to 500 NTUs to drinking water. This plant is fully gravitational, so the plant itself only needs energy for mixing and for dosing. And here in the left-hand upper corner, you see how this plant can look like, including a product tank and including a photovoltaic roof, which makes the whole plant energy autarkic. So the benefits or the features of this product are to produce safe drinking water from surface water that have it rivers. So the standard size of the plant produces in between 1,000 and 2,500 cubic meters per day. If larger capacities are needed, we would build or we would offer parallel trains or parallel units. We mainly remove particles, turbidity, organic carbon, and pathogens. And as mentioned before, this comes prefabricated and packaged in standard container formats. The second standard plant we have created is the seawater blocks. So here in the right-hand corner, you see one of these facilities as we built it in Iran for an industrial application. Again, we produce desalinated water from seawater for drinking or purpose process unit use. One unit is producing in between 500 and 1,500 cubic meters per day. And again, if larger capacities are needed, we would produce and set up parallel units. So the plant itself contains the whole pre-treatment, whatever is required. This always depends on the location, on the type of intake, and of course the desalination itself. Desalination by reverse osmosis or desalination in general is a very energy intensive process, as you know. So here our target is to achieve the lowest energy consumption on the market. We do that by using the latest stage energy recovery device, which allows us to desalinate seawater with less than 2 kilowatt hours per cubic meter. So summarizing, the advantage of this block system is that we are much quicker in realizing or implementing the plants. So in this graph, we compared an average conventional solution, which is tailor-made to the specific requirements, and the time we need if we accomplish the same task with a UNIHA block. And we can see we can realize such projects in almost half of time of a conventional solution. The main reasons behind this is that we minimize the fieldworks due to the prefabrication and the pre-engineering. We can minimize the footprint, which also minimizes the civil works required, which can be a big saving in time. And then again, referring to the topic of this workshop and the urban development, such a solution as our block solution is, for example, suitable for short-term use. So if you have a shortage in a certain area where the network is not yet developed, we could apply such a solution and use it for a couple of time. As soon as the network is closed and the area is connected to a bigger system, the plant can easily be removed and used in a different location. And of course, we are very flexible in terms of capacities by using parallel units, retrofitting them in the past, removing some of the capacity, moving it to other locations. Again, coming back to the topic of this workshop, the future is green and blue. In terms of water treatment, I think the main point is, of course, the energy consumption. What can we do as water treatment specialists? Of course, we can apply smart designs. Very obviously, the very first point is to use high efficiency machines. And of course, to use energy recovery systems. This is especially important in seawater desalination, and we have many cases where we show our clients the return on investment for energy recovery system. In most situations, you will see that a good energy recovery system is amortizing itself in a couple of months. What we can do is also to maximize a process recovery. If we have long intake routes, if we have difficult intakes, it may be better to increase the recovery of the plant, to save on intake. What is very important in my point of view is we need to consider part load scenarios. In many projects, we see that the plants are designed for a horizon 2035, even 2050, and where high increase in population increase is considered. As a consequence, when the plant is built, it needs to operate at part load, maybe 50%. And if the plant is not designed for such a part load, then this may result in very high energy recovery. So here we think it's very important to consider part load scenarios in the plant design. Then also we need to look into supply routes for spare parts and chemicals. Where are these parts available locally? Where are they coming from? Or can we maybe replace the process with a process that does not need chemicals? This can help in remote areas, for example. The other thing is to think in smart plants. With modern control systems, SCADA systems, it's easy to control the electric consumption and to move processes which are energy intensive to times out of peak consumption times. The other thing is we could think in islands where plants produce their own energy in photovoltaics. All of this is possible and can be customized to the specific needs in the city project. So this is my short introduction of Company Uniha, of our blocks, and what we could do to achieve a green and blue future in urban environments. Thank you very much, and I'm looking forward to answer questions, if any.
Excellent. Thank you, Dr. Schausberger, for introducing us this flexible and modular system of Uniha blocks. Yes, we have one more presentation to go, and then there will be time for questions. But as I said, one more presentation to go, and it's actually from our sponsor, ATP Water GmbH. Mr. Thomas Gerster, he pre-recorded his presentation, so let's listen to him for the next 5 to 10 minutes.
Volume, please.
Can you not hear?
No.
Okay, thank you. Let's try once more. Thank you. Let me try once more. Would be a pity.
Hello, everybody. Welcome to my
Yes,
today's
good.
presentation about a new idea, a new project, which is called Seawater. For this purpose, I will share my screen with you so that you are able to see the presentation. Yes, my presentation has the title Seawater, a close to nature system for management, purification and buffering of stormwater and surface water bodies, enhancing microclimate in urban areas, developed by ATP Water. My name is Thomas Gester, as I already told you. I was former head of export and now I'm taking care about special projects and networking. So first of all, I will give you a short overview about the company ATP Water that shows you a little bit where are we coming from and why we have this idea, which is not the frame of our normal program of our normal products. So we are a typical small middle-sized German company, which is in family, owned by family. And in 1999, there was a brilliant idea to change small wastewater treatment plants into the system of SBR, sequence batching reactors. And this was a revolution on the market, not only in Germany, also in Europe and nearly worldwide. Today, we are one of the leading manufacturers for decentralized and semi-centralized sewage technologies, and also an equipment supplier for biological wastewater treatment, also for bigger plants. We are offering maintenance and service, and we have subsidiaries in Belgium, France, and Romania, and more than 100 employees and multiple awards, which will be shown a little bit later. Shortly, our philosophy: we are doing a lot of innovations, but with the philosophy of simple de-engineered products that can be used nearly everywhere. Solutions from purification of the wastewater until its reuse. And this in technical or natural way, or a combination of both. Our idiom is a world with clean water. That's why we get up in the morning. What are the solutions, or which kind of wastewater are we serving? So the typical residential wastewater, that's for sure municipalities, but also buildings from a single house up to communities and so on, but also nursing homes, hospitals, hotels, restaurants, tourism industry, food processing, and very extensive part of our business is that you can imagine food processing is a very wide range. Also the wastewater of biogas plants and also temporarily used systems. What is our portfolio at the moment? Development, production, distribution of fully biological small and small-scale wastewater treatment plants. Small wastewater treatment plants run up to 50 people, small scale up to 5,000. Technical equipment for sewage technology, and also for the German market, multi-chamber tanks and collecting pits made of precast concrete. And this we support by a shop where you can buy accessories and spare parts for everything when you are working or dealing with wastewater. And we have an own service with maintenance and laboratory. So here at a glance, you see a little bit the figures of ATP, and we are really proud that we had in the last months that we have sold our treatment plant number 100 and 1,000. Yes, so now we come to our problem or to our presentation. What is the current problem or paradigm in intercity problems? So, you know, the ground is sealed and you have a high building density, and this means a concentration of storm water and complicated structures. So also in increasing heavy rainfall events due to climate change are also a challenge, like the increasing heating also due to climate change, and you know that buildings are staying a little bit longer warm when they are heated. Limited space conditions. Yes, that's for sure. The population density is much higher in cities than anywhere else. And until today, these problems have so far been addressed only insufficiently or only for individual aspects. Now, the Seawater is the only one system for all tasks, and it's a solution for an intermediate buffering of heavy rain events, a solution for the purification of this rainwater, the purification of surface waters, an improvement of the microclimate through humidification and cooling. And perhaps, by the way, it is also a system which could be used to treat really wastewater. But this is something that is a little bit more far away. What is the Seawater? The Seawater is a modular, above-ground, columnar biological wastewater treatment system, which is based on the trickling filter principle, and this combined with buffering capacity for stormwater. Water purification is supported by native plant species, which cover the outer surface of the reactor. You will see in the following slides. This not only improves purification, but also the microclimate in the surrounding area through evaporation. The following animated video shows how the different steps work and how they proceed. First of all, the working principle. The general working principle is with underground storage tank. You see here this underground storage tank, then a pump which is filling by a pipe the inner area of this trickling filter of the Seawater, and you see on the outside here the plants and the root area which support the treatment and which are also have the effect that the evaporation of the surrounding takes place. So a typical application would be a stormwater management. So you see here, you have an underground buffer here with a mechanical pre-treatment, so that a first rough treatment is made here underground, and where you have a certain volume where the water can flow in. And then you have the possibility, if there is not enough buffer volume, that you take also the inner part of the column as a buffer, and then the water will be treated by the trickling filter and the colognes here. And after the rain stops, the water will leave the column and will be let for a further purpose or wherever it has to go. Another application would be the lake and stream cleaning, so surface waters. You see here a pump also which pumps continuously the water inside of the Seawater for cleaning purposes. And when you have heavy rainfalls and the water level is raising, you have also the possibility to buffer a certain volume in the inner part of the column, which was shown here. The design is not reduced only to a column and to a circular. So if you combine several sew trees, you will create a kind of a sew wall, which then can enhance the microclimate by evaporation, which is shown a little bit here. So this is for you for a first impression to see what is possible, what can be made with a sew tree. And now please let me explain to you a little bit in detail the solution as an overview of technology. So the roots of the plants which reach into the outer ring inside the column. So you see here on the outside, you see the roots, the roots of the plants which are fixed on the outside. Then you have an inner pipe or an inner column which is filled with a trickling filter, and now it depends the buffer volume, what material you are putting inside. And you see here the inner circle with the filling material and the interspace volume as a buffer, and this can also compensate inflow peaks. The outer circle will be carrier material for the roots of the plants which are outside. We have made a testing phase in Vietnam at a lake which was used for fish farming, and you see here on the left side the picture which shows the 3 columns which have been installed over there. The left one is not yet in operation, and the other 2 ones are already, the plants are fixed on the outside, but you see they are still very small because it is in the beginning, in the initial phase. The right picture shows a top view on the head of the sew tree column with the distribution system. So the columns had 3 different equipments. So by filling material, root carrier material, and also by the plants that have been tested. In parallel, we made tests to look for other possibilities, how to fix the plants on the outside, about the root area, what can we do with that, and what kind of water, wastewater, rainwater, can be treated. The pictures were taken in the course of experiments, among other things, to feed filling material with different types of wastewater. On the left, you see the uncovered columns. In the middle, the columns partly covered with hemp mats. On the right, the final experimental setup without the sampling devices. And you see the plants are fixed with perforated wire or chicken wire. The tests were carried out with different wastewater concentrations. It was domestic wastewater. And also interesting, the filling material also, they were used on 1 Cologne plastic bottle caps as filling material. Data and information of the performance I will show you now. So you see here perhaps some interesting figures. The columns in Vietnam that have been erected over there had a height of 5 meters, an outer diameter of 90 centimeters, and an inner diameter of 60 centimeters. And the hydraulic capacity was 4.5 meters cube a day. So the energy requirement for this equipment, how it was made over there, was 0.5 kilowatt hours per meter cube. And the O2 concentration in the outlet was always higher than 4 milligrams per liter. The water temperature in the outlet was slightly lowered. The treatment performance results you see here now, the table shows the result of the sewer tree column 3, which performances the following equipment. The filling material in the interior was formed clay. The growth material for the roots in the circular ring was a mineral wool. And the planting on the outside was the plant Epiprenum aureum, which was made in a continuous operation. The photo here next to the table below shows the results visualized. In the left bottle, you see the incoming water from the pond with the fish farm. In the right one, the outgoing water. The photo above shows which improvements in performance are possible in a recirculation operation. You see here really what is possible if you have the possibility to let the water flow several times through such a column. The column filter material in columns was shredded coconut shells. The root zone material was coconut fiber. The planting was suppressors, macrobia, and other ones. I don't want to bore you with all these details, but what I told you in the beginning was that really the plant Epiprenum aureum, and with a continuous operation and the mineral wool, had these really good results. Yes, perhaps to summarize a little bit what we did, the concept has proven to be feasible and efficient. The plant used Epiprenum aureum is well suited for planting. The pictures on the picture on the right here shows you the condition of the planting, especially the sewer tree 3 in the middle with mineral wool as root material, and this Epiprenum aureum as the only planting in the entire surface area after only 4 weeks. The sewer tree slightly cools the water, which felt had positive effects on the environment. Yes, I think what is also interesting for you, it is the cost and financial benefits. For example, the production cost of a handcrafted column. Only the column, no foundations or similar, can be estimated at 3,000 to 6,000 euro under experimental conditions. Mass production. So, for example, energy optimized units and solar panels can reduce the running costs, and perhaps also look that a mass production can reduce the cost of the capex here to realistic 3,000 euro or less. But this is still a wide range of activities and investigations to be made. And the OPEX, the operational costs, can also be lowered by energy optimized units and solar panels. And what is interesting also to make coordinations with other infrastructures that can generate revenues. For example, street lighting, mobile network, information advertising screens, electrical charging facilities. The combination of buffering, retention, and water purification, as well as the improvement of aesthetic appearance and climate in the inner city, results in considerable cost savings. What is the status of development and the way forward? Yes, you can say the sewer tree concept is still in a relatively early stage of development. The Vietnam pilot project proved that the concept is feasible and efficient. This was also confirmed by subsequent investigations at PIA From both, I showed you some pictures and the results. And in addition, the following issues have to be still clarified. Constructive final structure of the pillar or the column, the materials with regard to suitability and production, which plants are suitable depending on the climate zone. So, for example, the Vietnam test showed that this plant was very suitable for Vietnam or for Vietnamese climate conditions, but perhaps in Europe you need other plants. And the development of an optimized manufacturing. Values for urban or landscape planning and urban development are still needed. And other topics. Summary and next steps. The SUTRI concept is suitable to offer solutions for current and future challenges of inner city areas. The basic suitability and first rough design and dimensioning could be determined. Open questions, see the slide before, are very important to be answered for a marketability expertise. Additional pilot projects and expertise still have to be made. And later, perhaps, an outsourcing of the SUTRI concept and also potential products business areas that arise from these activities. You remember the presentation of ATP Water. We are close to these activities, but this means a different business. Yes, the use of the SUTRI in public areas will still require a lot of supplementary research with various tests, pilot plans, and as well possibly required approvals and certificates. But a little bit to pour a little bit water into the wine, within the framework of an internal ATP strategy meeting, we have decided to push the product or this idea first only for a very small market segment, namely as a cleaning system for private pond facilities. Thank you very much for your intentions. For further questions, you can please contact me by my mail account you see here below, or you can contact directly ATP Water, which is located in Porta Westfalica, So I would like to thank you again, to say goodbye, and still have a nice and successful conference. Goodbye.
Very good. I mean, this basically concludes the presentation. So I heard that not everyone saw the movie in a smooth manner. So of course we will share as well the link to it, so that you can really look at it in detail. And if there is any question, again, you have the contact details of Mr. Gester as well in there. So we are coming to an end of our webinar. There was one question. I don't know if Mr. Olivier from Deso Architects is still in the call.
Yes.
There was one question to you. Can you give us some recommendations on how to ensure water security in big cities such as Hanoi and Ho Chi Minh City?
The question is always the same. This is also the conference and the webinar we have. We need to reduce the water in the network. So I'm not technical engineer, but we need to have more nature in the city. We need to have more place where we have permeable area. We need more square. The problem in Vietnam also, there is no regulation for the roof. In Europe, we have many regulations to stop the water, especially, for example, in France, we need to have a percentage of water that we need to keep. We cannot have the water in the same network. Oh, every engineer knows that. But the most important is to have more place for permeable area. This is now the big problem in Vietnam, and we have discussed about the concrete. One of the intervenant before speak about that. The question in Vietnam soon is we have a lot of mineral area, and this problem will be soon a very big danger, especially in big city, where in Ho Chi Minh City and in Hanoi, the periphery of the city make bigger and bigger, and we will have soon and sure more and more flooding problem. So the best way is to have in a local and for individual proposal, if this is a different scale, we need to have garden, we need to have trees on the building, we need to have on the rooftop, we need to have permeable area, many recommendations.
Okay, very good. Thanks a lot for this. We have one more question I see on ATB, and I think Frank, you can answer this. What kind of plant species are you using for the Su tree?
Yes, thanks, Bruno. I think I can answer that. Actually, it was mentioned in the presentation. You have seen that plant, which is a very common plant in Vietnam. I don't know the Vietnamese name. I can't remember the Latin name either. But anyway, it was mentioned in the presentation, and we will be circulating that.
Okay.
The other part of the question was whether those plants are suitable under German conditions. Of course not. So every region will have its own specific plant species. This is the challenge for the planners and project developers.
Very good. Okay, so well, we are coming to the end of this webinar. I would like to warmly and heartily thank to all the presenters for taking the time and for sharing their experience and expertise. I personally learned a lot, and I'm sure everybody did as well. So let me hand over for the closing remarks to Frank. I mean, you're already on screen. You are representing the water working group of our Green Growth Sector Committee of EuroCham. So please, the concluding remarks from your side, Frank.
Thanks, Bruno. Since EuroCham and the Green Growth Sector Committee are the co-organizers of this event, it is with me as the head of the water working group to wrap up and find a few closing words. Actually, I don't want to make it too long. I think what we have learned is that blue and green infrastructure is definitely something that has to happen in Vietnam. The problems are too large. We see a rapid urbanization that cannot be solved without the integration of blue and green infrastructure. We have learned about potential solutions. Yeah, I mean, DESO architects offer landscaping solutions that are most suitable for this kind of problem. Inteva offers infiltration systems for stormwater. Advanced Enviroseptic are offering decentralized wastewater treatment solutions. We have learned from INSEE that there is permeable road surface around that makes a lot of sense. ATB has developed a decentralized system for surface water control and purification, and so on. I think now it's time to talk about policy making. It's time to improve the legislation. It's time to carry out more pilot and demonstration projects. And I think most important, it's very important to look into capacity building. The planners and engineers in Vietnam, they have to know about this. They have to know what it is and how to apply. So this is actually my wrap up. Thanks again also from Green Growth Sector Committee to all the presenters and speakers today. We will be sending the presentations and the movies around. Don't hesitate to contact us. Most of us are located in Vietnam. So very happy to talk to you again. Thank you very much.
Thank you. Thanks all. Have a good Friday afternoon, evening, and tomorrow is World Environmental Day, so I think as well fitting pretty much into the topic and that we had today. So thanks everyone for your valuable contribution.
Thank you.
Bye bye.